Okay, so today we're going to have a look at simultaneous equations. Okay, now before I dive into simultaneous equations, I want to have a look at linear equations. Okay, just a simple linear equation, right? Let's say we have the equation 2x plus 7 is equal to 10. All right, now this equation has one unknown. All right, and it's just one equation. So therefore, you can solve this equation very simply, right? You can say, you can take the 7 onto this side, it becomes 2x is equal to 10 minus 7. Let me just write that properly. 10 minus 7, right? Which is 2x is equal to 3, right? Divide both sides by 2 and you get x is equal to 3 over 2, right? In this case, solving a linear equation, you have one proper answer. Okay, now let's look at an equation. Okay, for example, 2x plus y is equal to 5. In this case, we have two unknowns. Right? How would you solve for this? You can't make, if you were to make x the subject of the formula, you'll be left with y on one side. And if you were to solve y as y as the subject of the formula, you'll be left with x on one side. Right? So in this case, we can have a pair of solutions. Right? A pair of solutions. Okay? Where x is equal to something and y is equal to something. Okay? For example, let's draw a table. Let's just quickly draw a table. Okay. And you have values of x and you have values of y. Let's say if I was to plug in, for example, the number 1. And let me just make 3 columns. 1, 2, 3. Okay. Let's say if I was to plug in the number 1 into this equation. Okay. What would I get? I'll get 2 times 1 plus y is equal to 5. Now you're left with one unknown. So you can solve for y and you get y is equal to 5 minus 2 and y is equal to 3. Right, so we know that y is equal to 3. This is a pair of solutions. All right, for this equation, right? Now we can have a look at more examples of pairs of solutions for this equation. For example, 2. Let's say if I was to plug in 2 into this equation, I'll get 2 times 2 plus y is equal to 5, which means 4. Or let me just, y is equal to 5, where 2 times 2 is 4, minus 4. And you get y is equal to 1. Okay, you get y is equal to 1. So when this is basically saying when x is equal to 2, y is equal to 1. And this is another pair of solutions for this equation. All right, now let's plug in 3. You get 2 times 3 plus y is equal to 5. Say y is equal to 5 minus 2 times 3 is 6. And therefore y is equal to -1, right? -1. So all of these are pairs of solutions for this equation, and we can do this so on and so forth for as many numbers above 3 and 4, 5, and all below also, right? We can go into 0, -1, -2, and so on and so forth, right? And all of them would give you pairs of solutions for every x you get a specific y, for 2 you get 1, for 3 you get -1, and so on and so forth, right? Now let's look at another equation, right? Okay, let's say you have x plus 3y is equal to 5. In this case, again, there are two unknowns. Okay, so let's draw our table and find just random, just any values of x, right? X and y that will give you a specific value for y. So let's use the same as what we did before. We'll plug in 1, 2, and 3. These are just random values I'm selecting. Okay, if I was to plug in 1 in x, right? 1 in x, I'll get 1 plus 3y is equal to 5. Now we can solve for y. We will get 3y. Let's do this. 3y is equal to 4. And therefore divide both sides by 3 and you get y is equal to 4 over 3. 4 over 3. Now let's plug in 2 into for x. You get 2 plus 3y is equal to 5. Right? Now we can solve for y. We get 3y is equal to 3. And divide both sides by 3 and you get y is equal to 1. And that's 1. And for 3, if I was to plug in the value 3 for x, I'll get 3 plus 3y is equal to 5. I'll get 3y is equal to 5 minus 3, which is 2. And therefore y is equal to 2 over 3. All right. And you can also go on and forever and right. Now, if I was to look at both of these equations and the solutions for both of these equations, both of these equations have solutions that solve them both simultaneously. If you look at, let me just change the color. If you look at this solution here, 2 and 1, right? And this 2 and 1, this pair of solutions solves this equation and this equation simultaneously, right? So that would be your pair of solutions. And these pair of solutions can even be shown graphically, right? So let me just show you how it will be shown graphically. If I was to draw, let's say, axes, all right, let's say 1, 2, 3, 4, 1. I'm not going to be too accurate here, but it's just to show you how you can find the solution to these equations graphically also. All right. Now for the first equation, we had 1, 3, 1 and 3, 2 and 1, and 3, -1 as our coordinates, right? So 1 and 3, that will come somewhere there. All right. 2 and 1, that would be somewhere there, and 3 and -1, which would be somewhere there. This would form a straight line, right? I'm sorry, that's kind of crooked, but you get the point. Right? Now the second equation, which is this one here, if I was to plot this on a graph, I would get 1 and 4 over 3. 4 over 3 is 1.33 and so on, right? So 1 and 1.33, which would come somewhere there. Okay, then you get 2 and 1, which would be there, and you get 3 and 2 over 3. 2 over 3 is like 0.67. 3 and 0.67. This would also be a straight line. All right. Now these lines can be plotted like on using different values of x. You can go on for like hundreds of values, right? So I'm just going to draw these arrows to show that this is continuous for more numbers than what I've shown here, right? You can go into the negatives, positives, etc. Now if you look at this carefully, this is an equation of, let me just see, 2x plus y is equal to 5, 2x plus y is equal to 5, and this is x plus 3y. X plus 3y is equal to 5, yes, it's 5. Right. Now you can see that these lines intersect. Let me change color. Intersect at this point, right? And if you look at the coordinates of this point, it is 2 comma 1, right? So that is a solution that satisfies both of these equations. And if you come back here, you notice that this is also 2 and 1, and this is also 2 and 1, right? So this solves both equations simultaneously. Now, it just so happened that I plugged in a few values, 1, 2, 3, and I happened to get a solution. All right. What if the solution happened to be in the hundreds? I wouldn't write 4, 5, 6, and so on, all the way to 100 to find a solution. Therefore, there are actually methods that make this easy for us to solve. And those are the substitution method to solve these simultaneous equations, and the second method is the elimination method. All right, and in the coming videos I will further discuss these two methods.